Thank you very much for the introduction. So, hi, my name is Raluca Gaina, and I am currently a PhD student at Queen Mary University of London doing artificial intelligence. So this will probably be the least technical talk that you'll be seeing at this conference, but I hope that you'll find the ideas behind the project and the work that we've done interesting. And if you have any ideas or comments on how we can take this even further, then I'd be very, very happy to hear about that and have a chat afterwards. So I'll start by talking a little bit about the broader domain that this work is part of to motivate sort of the context for the talk and why we even started doing this in the first place. And that story starts with the domain of general video game playing. There have been many artificial intelligence players over the years, and these have been with varying degrees of success. But actually, a lot of milestones in artificial intelligence in general have been in games. Games like chess and Go, more recently, are key examples of how technologies were developed for games and game playing in particular. But these were then taken further into different domains and different applications, and very successfully so. There have been applications, for example, of protein folding in medicine, which is quite far-fetched from game playing, right? So the application of all of these methods is not really limited to games, but games are a great testbed for developing artificial intelligence methods. They are fast, you can simulate different things very quickly, they are easy and cheap to fix if they break, as opposed to robotics, for example, where buying some new parts would be a lot more expensive. And you can simulate real-world situations, and this could go from very simple problems like just moving a box around to huge open worlds where players have to explore and get involved in this new world that has been created for them. And there's also a wide variety of games out there to cater for different players and different play styles, from some shooters to puzzle games to adventures, and yet a lot of artificial intelligence techniques that were most successful and those making it into media these days, like the artificial intelligence players for StarCraft or Dota 2 that you might have heard of. These AI players are tailored specifically for those particular games. The knowledge about the game is embedded into the artificial intelligence, and if you took the exact same algorithm and asked it to play a completely different game or do another task, then it would most likely fail quite miserably, if it doesn't even just crash. And that is where the concept of general video game playing stems from, having an artificial intelligence player that is able to play any possible game that is given to it or solve any possible task. And that seems a little bit quite crazy, that the AI would be able to play anything even if they don't even know what the game is about. But the state of the art in this domain currently are some methods called statistical forward planning, which use an internal model of the game to be able to simulate what might happen in different situations. And they make decisions based on that. And this usually works quite well, but there are still a lot of games that are too difficult for these methods to solve, even if they might look very easy to humans. And they generally rely on some symbolic information about the game to make decisions. So the different game objects, their positions, and different properties about these. And another large category of methods relies on visual information instead. They would look at the screen and use that information to learn what to do in the game, what's good and how to win that game. And these methods are becoming more and more popular these days, with the arguments being that that is how humans perceive games. They look at the screen, and based on what they see on the screen, they decide what to actually do in the game. But this is also adding an extra layer of computation for the methods. They have to process that visual information to be able to actually understand it better. And it also restricting the information received to what is visually displayed on the screen. But this is a great approach, and AI players are starting to experience the games more like we do, right? But there is a key element that is often ignored in all of these methods, in all of this game playing research. And given where we currently are, you might be able to guess what that is, and it's audio. But sound and music in games have long been key to player experience as well as gameplay itself. Audio can greatly influence our engagement and emotional investment in a game, but it can also provide important gameplay information or cues. Rhythm games are one example of a game genre where audio is key to gameplay, as the player should perform actions in the rhythm with the music. And other games could also require the player to listen to different sounds and understand them in order to be able to progress. In some games, particularly horror games, they rely heavily on audio to create an immersive atmosphere for the player, and much of the impact would be reduced without all of that. In many games, audio is used in combination with other types of feedback for the player to create a wholesome experience. Some games are actually specifically developed with only audio input and no other sensory information. So there would be no visuals or haptics, or from an AI perspective, no symbolic information about the world either. Humans are fairly good at distinguishing sounds and properties of different sounds. For example, hearing an alarm, if this plays, would probably mean that something bad is happening or about to happen. Or hearing a slashing sound could mean that someone is probably waving a sword nearby. AudioGames.net has a fairly large database of such games, which anyone could download and attempt to play. And if you do, you should be prepared to be immersed in a world of complete darkness, where all you have to guide you is sound. Footsteps, yells, slashing, and punching are most commonly used sounds in these games, which often focus on the action or adventure genres, probably because these are naturally relying on sounds to portray gameplay information to the players, as opposed to, say, a maze navigation game where the position of the player would be more difficult to portray through sounds. And despite the difficulties one might face in such a scenario where all you have is sound, there are blind professional players out there whose every game is an audio-only game. And they can compete and be really good at fighting games, for example. There have been speedrunners who attempted to finish games while blindfolded. And in order for all of this to be possible, the games need their audio to be well designed to be able to describe the gameplay that a player cannot see. And even if a player can see some visuals, an interesting challenge to both humans and artificial intelligence players alike is partial observability. That is, situations in which part of the game information is visually hidden from the player. And this could happen in a foggy environment like the one displayed on the slide, but it could also be in map-based games, for example, where part of the maps that haven't been visited yet are occluded by fog of war, or while running down a corridor and you can't really see around the corner to see somebody possibly jumping out at you. And this could also be the case in a first-person scenario, where all your field of view is limited to what your avatar in the game is able to see, and you could easily be missing a sneak attack from the back. In these scenarios, many games use sounds to inform about non-visual information, which is outside of the general field of view, such as footsteps of other characters to signal position, or alarm systems in stealth games, which could indicate something new happening that is not visually displayed yet. And one very interesting game that portrays partial observability as a gameplay mechanic is Unfinished Swan. Here, the player starts off with a completely white screen, and they have to throw paintballs at the screen to be able to reveal the shape of the environment and the game objects around. Although the sounds made by the paintballs could be occasionally distracting, the hitting of objects of different types, such as ground versus water versus chickens at some point, this produces different sound effects. And one could use the delay between the throwing action and the actual landing noise to figure out distances as well as object types that are revealed in the game. So having all of this as our motivation, we extended a general video game artificial intelligence framework to allow for general purpose players to try out some audio games. GVGAI is what we used, and this is a framework widely used in research that contains over 160 games, both single and multiplayer, and different challenges for artificial intelligence to build levels or generate game rules or play the games from symbolic information or visuals via planning with a model of the world or just learning how the game works by playing it repeatedly. But all of these games do miss the key aspect of audio, and that is what we tried to embed into the framework. And you could find this code on GitHub, but do keep in mind that this is still very much a work in progress project, and there could be some weird things going on there. So our modifications here start with the language that the framework uses to describe games. And we're allowing now the possibility to play different audio files for actions that game objects can take in the game, like moving or shooting, or even some beacon sprites, which are some objects that constantly emit a sound over a certain number of game ticks. And interactions are also enabling sounds now. And we've also added a special interaction that only plays sound effects and has no relevant gameplay effect. And then we offered all of this information to the artificial intelligence players that we wanted to try out audio games. And this includes the intensity of the sound as well as some extra information extracted from the audio file. And lastly, we took away all other observation types, all visuals and symbolic information, and implemented 3 different games that only have audio input to guide the players. The first one, Aliens, is an adaptation of the classic Space Invaders. And now this provides the player with various information about its shooting and hitting of different objects in the game, like different aliens or hitting bombs or protective bases, with some additional feedback if the player is trying to leave the game area. We have Labyrinth, which is a maze navigation task, and this signals the player when they bump into different walls, so they're trying to take an incorrect path towards the exit. And we've also included a beacon sprite for the exit that is constantly emitting the sound and trying to sort of guide the player towards where they're actually supposed to go. And finally, Bloodshed is a very simple fighting game in which the player can just move left or right and wave a sword in the direction it is currently facing, and the enemies will be coming from both directions, and the player is trying to survive as long as possible. And then we used 2 different artificial intelligence players using the same method, but different information that they receive from the game to make their decisions. So one player would keep track of all of the individual sounds that it hears and also learn some associated rewards with that. And this agent is binary. If I hear this sound, I just get a particular reward. And the other agent would keep track of individual sounds, but also differentiate rewards based on the sound's intensity. So if I hear the sound nearby, I get this reward as opposed to hearing the same sound further away. Neither of our players actually performed brilliantly on any of the games, which was not very surprising. We used very simple methods to guide them, but they did provide some interesting insight into what learning from audio observations might mean for these players. In the maze navigation task, for example, the first agent with the binary memory, it never manages to win the game, and it learns that both of the sounds it hears are just bad because they never lead to actually winning the game. It does manage to do that. but the constant exit beacon sound, since it hears that at every game tick, as opposed to bumping into walls, which is sort of its own choice, the beacon sound becomes worse valued than the other one. So we think that given more time for this agent to learn how to play the game, it might learn to stop bumping into walls and possibly find the exit, but it probably struggled in doing so. Whereas the second agent, which takes into account the sound intensity now, this doesn't win very often either, but in the few games that it did manage to win, it learned that it is good to hear the exit sound close to itself. So this agent probably would manage to actually learn to consistently find the exit with a little bit more time to learn the game. Similar to how feature selection plays a big role in symbolic or visual learning artificial intelligence, it is important to take into account the level of input offered to this game-playing artificial intelligence. And we can easily make a parallel between the design of audio games and orchestrating some large musical pieces with several instruments. And in our case, all of the sprites and all of the interactions between them that produce different sounds could be different instruments that all put together would make, hopefully, something interesting and useful for the players. But overlaying too much input would make the game unplayable and just turn into undistinguishable noise for humans. And with too little input, you would not actually have enough information about the gameplay to be able to figure out what's actually happening in the game. So for a balanced design, we propose some different analysis options for the audio games themselves before even thinking about the players that are going to be playing these. So first, we can look at some visual representation of the observations that the agents see. So this is sort of what the AI players see in the game from the audio input that we give them. And it's interesting to note that although between ticks, game tick 60 and 85, so where the red signal stops there, no more shooting occurs, but the player does keep trying to do it. And that is because of the rules of the game where there can only be one bullet in play at a time. And the player doesn't really know that because he doesn't know the rules of the game. But it could use this sort of, the effect of its actions and the audio input to be able to figure out how the game might actually work and improve its performance. And then we also propose automatically getting rid of some non-essential sounds or misleading audio signals. If we look into an AI player's memory and check sort of the rewards associated with all of the different sounds, we could consider that the sounds with rewards close to 0 are, so they're neither positive nor negative. These are probably not really essential to gameplay. And the sounds that have highly fluctuating rewards while the player is learning to play the game, those are probably misleading. So taking this sort of feedback and analysis into account, audio in games could be further improved to provide some interesting, useful, and clear information to the player with the help of these game-playing audio AI. And there are many more research directions opened by this work. One to highlight would be audio analysis for understanding what different types of sounds mean and using that knowledge in other games, as well as combining this with other sensory information for a more complex and complete view of the world in decision-making progress. So moving towards more general artificial intelligence that is able to deal with many different situations. And this research can also be used in game testing with a focus on inclusivity and accessibility. AI agents that are able to successfully play a game from audio observations only could indicate that the games are suitable for the visually impaired demographic. Or they could suggest changes to be made to the games to widen the game accessibility in order for the games or the playable experiences to be enjoyed by as many players as possible. And concluded with some future steps of what we're going to do next, we don't really have a concrete plan for this, but we do have some ideas, some that we've already mentioned. But moving on, we would like to make the whole methodology more easily accessible and also easier to work with. The framework that we've implemented all of this in is written in Java, and we've struggled to actually make sounds play nicely into the games and use all of the nice information that we would like to for the artificial intelligence analysis later on. First step that we've considered is moving into Unity, and a few people that I've spoken to, they are very much interested in possibly collaborating on this and trying to expand this into Unity. That would allow to more easily set up sounds in games, but also open up some interesting possibility of exploring some binaural audio and generally audio with more meaning inserted into it, like the position of the players or the directions from which the player is actually getting attacked from, as opposed to there's just an enemy coming at you. And these are mostly some ideas and feedback received from others that we've spoken to. And I'd be very much interested in hearing what you guys have to think about all of this, and if you have any ideas for what we could do more. And if you'd like to be involved in the project, I'd be very happy to hear about that. My email is there at the bottom, and there's also a QR code if you'd like to read the paper that we've written on this and get a little bit more information about everything. Thank you. I'm very happy to chat over lunch as well, if you prefer that, since lunch is there. Yep, I know.
When
Yep.
you look at the more traditional ways that if you watch like speedruns being learned on a game.
Yeah.
Yes. Sorry. If you watch like videos of speedruns being learned over the game, do you know if they are using any audio cues, or is that all purely blasting away on a graphics card looking at pixels?
I think audio is a big part of how humans play the games. And especially if you're doing it at a very fast pace, then you might not be able to see all the details in the graphics that would actually be giving you that information that you need to progress. But there are specific audio cues that they will be looking for and trying to trigger those as opposed to some specific visual information. So I think audio is really key to this, and more people should be looking into this.